Good morning, everyone. Good to see you, and welcome to Glastonbury. Wrong event. That was last week. As the introduction said, I want to spend the next few minutes explaining a little bit the link between increasing asset resilience and the effect they can have in reducing the carbon emissions in relation to the management of street ironwork. One thing is for certain, access covers, gully gratings are an integral part of many of the networks that we see across, from telecoms to water, from residential to distribution. Regardless of who the network owner and operator are, they all share some common issues, which is the frequent replacement and early failure of ironwork installations. I want to share this number with you. So 200 kilograms of CO2e is the amount of emissions that could be linked to the replacement of a piece of street ironwork. The example, yes, it's worst case, but the example is for a typical 600 by 600 D400 carriageway access cover. So every time one of those is replaced, there is that carbon impact, not just the financial cost, but the environmental cost as well. 120 kilos are the embodied carbon of the product itself, whereas 80 kilos is attributed to the equipment, the materials, the waste and energy that's used during their restatement process. So reducing that reinstatement frequency, that replacement frequency, will have the net result of reducing the carbon emissions associated with managing this type of asset. There's a growing body of research. The most recent is from the WRC, the Water Research Council, where they did quite an extensive study into the modes of failure of street ironwork. And their results are on the screen now. So they said at least 50% of the covers they see fail is as a result of what's called seating wear. And that's a sign that there's instability. Something's not quite right between the mechanical bonds between the ironwork and the surrounding road surface and the structure below. They said at least 40% will lead to eventual paving failure as well, pavement failure. And at least 30% can be attributed to the materials used to install the ironwork to begin with, so that the bedding materials, as it's often referred to. This short video shows what's happening underneath the surface. So you can see there's a lot of differential movement here between the ironwork and the surrounding materials. What's happening here is the material is being placed in tension. And that is the critical mechanism here, is what causes early failures. Because often we see materials used that don't have any tensile properties. So high strength concretes rather than modified cements and mortars. So that's the key thing to sort of bear in mind and consider as we move through the slides. So, simple question: how can these failures be avoided? I want to introduce a different word. Instead of innovation, I want to call it systemization. Let's think differently about how we approach the management of street ironwork through not just installation, but ongoing maintenance replacements years into the future. So how do we do that? We combine a number of different factors. So correctly designed and specified ironwork is key. Not all products are the same. So we need to explore that. The use of high performance materials to install the frame as well. So bear in mind the stresses, the forces that are going to act on that from passing traffic. The work techniques and the work practices that are employed as well. Trained, qualified operatives. Ensure that they are aware of what best practice right first time techniques represent. And also the chamber itself. We often see very unstable structures underneath our products, our ironwork, so chamber condition is critical as well. So just unpick what those various steps are. So what guides product selection is a specification. So what we would suggest is specify a product not just by load class, but by the environment in which it's going to be situated. Consider traffic speed, intensity, the type of traffic itself. What is perhaps a quiet road today might be a busy diversion route tomorrow, or it might be a bus route in the future. So factor that into your specification matrix. There are a number of great examples out there, and one often most quoted is a National Highways document called CD534. I'm assuming some of your people are familiar with that. What it does, it specifies the requirements that a piece of ironwork has to demonstrate within a busy road network. So it looks at performance features of the ironwork itself and how it interacts with the materials and the road surroundings. It sits within the DMRB. It is currently being updated, but I think most of the fundamental principles will remain. It also looks at certain vehicle movements, traffic intensity, and it will suggest a different type of product is used in those different environments. There are other documents as well, and often these are read in conjunction with each other. So for the utility-facing organisations, they've got what's called SROH for short on the left-hand side. The document in the middle is an excellent piece of work conducted by the RSTA. They have a stand here today. So go and have a chat with Sarah and the team just to think a bit more about what that code of practice contains. There's some really, really great information in there. All brought together by a number of sort of knowledge experts from across the industry, so manufacturing, suppliers, end users as well, and consultants. Then the final document is a supplementary standard called BS 7903. It's a supplementary standard to our manufacturing standard, which is EM124, but it's written from a user's perspective rather than a manufacturer's perspective. Again, in essence, common sense recommendations around how to manage street ironwork. Staying within the DMRB, I hope you're remembering all these because there's a quiz at the end, by the way. So within DMRB section Series 500, they specify the type of material that should ideally be used for installing carriageway artwork. It looks at its mechanical properties. It looks at its workability. Yes, it looks at its compressive strength, but most importantly, it looks at its tensile capabilities as well, and how quickly it gains that 5 Newton strength within a 3-hour period. So that is a critical thing to remember when writing into your specifications the materials that should be used by your delivery partners when dealing with ironwork. Look at the chamber condition. Is it stable? Is the surface prepared correctly? Openreach have introduced an element of their specification to do a pre-condition check of the structure itself. So don't just inspect the ironwork, inspect what's underneath it as well. Make sure it's compatible in terms of the ironwork that's going to be used. So we've got, again, some obvious but some logical recommendations as well. You know, is the depth sufficient to allow the optimum amount of bedding material below the frame? Is the chamber itself solid? Is it structurally sound? And also look at the size of the opening in the chamber compared to the opening of the ironwork. What you don't want is the frame of the piece of ironwork suspended in free air, because all you'll get is that differentiation in movement, so it needs to be fully supported. Work practices. If you remember from the research, it suggests that more work or more attention could be paid to the techniques that are employed to install this type of product. So again, allow enough time for your contractors to do it right first time. Often there's too many time pressures placed on them to open the road within a matter of hours. You need to allow enough time for the materials to cure correctly, to gain that optimum strength, and it's that 3-hour recommendation. Look at how the chamber is prepared. Look at how the trim back is created with the space in which they're working in. Don't run a mechanical vibrating plate over a piece of ironwork after it's just been installed. Take care, compact around the edge of the frame rather than over it, because if you compact the frame itself, it will break the bond that's been created. So again, you're just creating an early failure mode, which could be avoided. We often see the right materials used in the wrong way, not enough of the right materials used, or the wrong materials used completely. Don't just use sand and cement. Use a correctly specified material, because that's the way you increase durability and increase reliability as well. And I've also talked about this. We often see access covers and gratings misaligned to the chamber completely. You have one side that's supported, the other side's not. You have it completely shifted over from one side of the opening where you've got almost like a free avoid the other side. Make sure that the frame is centrally aligned and fully supported, whether it's on a circular gully pot or the square opening within chamber structure. So this is a bit before and after. So the one on the left is the video you saw earlier, whereas the one on the right, you have to look carefully because there's hardly any movement on the one on the right-hand side. So here you've got the outcomes for following that system approach to the installation of ironwork. So just repeat it again. So before on the left, showing the differential in movement and the materials being placed in tension, to the one on the right. Okay. So the one on the right is the system that's been adopted by a number of utility companies in the UK across the water sector and the telecom sector as well. So why not introduce this approach into the local road network as well? It's still a piece of ironwork, so fundamentally the way you deal with it should be exactly the same. Just want to finish with a reminder that for every piece of ironwork that is replaced, you've got the embodied carbon of the product itself, which is 120 kilos on average. But then you've also got the 80 kilos of emissions that are generated through every replacement. So by reducing that frequency, you reduce the emissions generated as a result. Thank you very much.